Hi, so in this video we're going to look at how we can actually calculate an expression for an entropy process, for a process. In this case we're looking at an isothermal, isothermal expansion, right? We are increasing the volume here. So we're going from P1 V1 T1 to P2 V2 T1, right? So temperature is staying the same. So this is an isothermal process. And we could imagine up a couple other ways that we can get from P1 V1 T1 to P2 V2 T1, right? Where we change the temperature along the way, or maybe do isochoric or isobaric processes. And we'll be looking at those when we meet together in class. But we'll start with the isothermal example, where we just have a simple path. All right, and so what we need to know is what is dq reversible over T, right? What is the reversible heat transfer for this process? Now, we're going to need to use the first law of thermodynamics, delta U equals dq plus dw, to be able to figure this out. And if we can figure out what delta U is and dw is, then that gives us an expression for dq, and then we can substitute that into the definition of ds. It's equal to dq reversible over T. Okay, so first thing we can do is say, well, we know that delta U is CV dt. dq we'll just leave as is, and we'll do this for a reversible process, right? Because that's what we need to find is dq reversible. All right, and so the reversible work is given by minus P dV. Okay, and so we have our expression here. But this is an isothermal process, so dt by definition is equal to 0, so delta U is equal to 0. So we can say that 0 equals dq reversible minus P dV, and so we can say that dq reversible is equal to positive P dV. And now we can go ahead and make the substitution that we know what P dV is, P is for an ideal gas. Again, we're assuming ideal gas behavior, nRT over V dV. And so if we want to find ds, well, that's going to be equal to this expression divided by temperature, right? So ds is dq reversible over T, which is equal to nR over V dV. And then we just need to integrate this from V1 to V2. So if we want delta S, we need to go from 1 to 2. And integrating this expression here, we're going to go from V1 to V2 since we're integrating over dV here. And so that is a pretty simple integral to do. We've seen this one a few times now. 1 over x, integral of 1 over x is log of x. So we'll get delta S is equal to nR log V2 over V1. And that gives us our expression for the for an isothermal process, what the change in entropy is for that process. Now what we're going to look at in class is if we do this through some other means, we'll still get this same answer, even if we use a different process to do this, even though the heat will be different for all those processes, right? Because heat is not a state function. The change we get, the delta S value we get, will be the same. And so it doesn't matter which way we calculate it, we'll still get the same answer, which is nice. It shows us that this is a state function.